we are going to see an example of an event-driven or automatic action. In this case, we receive periodically information, for instance, from speed. I don't remember if it's once per second or twice per second, but the cell phone sends this information to the through web sockets to the driver agent, and in the driver agent we have this class which is memory, which has speed events, and this is stored as a speed event. Okay. In order to be retrieved by other functions. And we also have the object detector that in this case has detected a speed limit sign, a 20 kilometers per hour speed limit sign, and it's providing the track ID. The track ID is necessary to distinguish an object between frames. When you are evolving in the different frames of the video, you want to recognize that this object, this instance, for instance, of an speed limit sign, is the same between all those frames. And you don't need to classify it as a different object, but the same object. And the track ID is the one that allows you to do this. And then you have the position, which is, let's say, a calculation made over the bounding box. Bounding box is the thing that it's around the object, and it's typically detected by object detectors. And we calculate the center of the bounding box. If it's on the left, on the center of, or on the right, this is codified as the position. And finally, of course, we have the class, in this case, the speed limit. What is happening here? Well, we receive this information. We detect this is a speed limit sign. The fact that it's 20, it's not detected by the object detector, but an OCR package that works after this. And we create a MADA object, in fact, a subclass of a MADA object, and there is a space event for this MADA object, which has the object has a method that is manage space event that checks the current speed against the speed of the sign. If the current speed is greater than the speed of the sign, then there is a warning sent to the text-to-speech system in order for the driver to know that she or he must reduce the speed because it's greater than the speed limit one. This is the automatic way, and this is just one example. We have much more examples, like with give way signs that the system wants you to stop, or traffic lights, or anything like that. There have been videos about this before. This way of working of the automatic actions or event-driven actions is, let's say, it's a classical approach in driver assistance. It works fast, but it's rigid because it just can't work with the functions we have predefined. By the way, these functions that you have predefined are used both in the automatic way and also in the driver request initiated actions, as we will see. Let's see an example of this automatic action regarding speed limits. Here we have a video of MADA working. As I said at the beginning, it's very simple. There is no fancy interface. We just have here the terminal for the driver agent. We have here the terminal for the object detector. Here is a mirroring of the phone. In current versions, I'm not using it anymore, but in this version, I was still using it. It reflects both if there is any conversation from the driver and also the speed here. And here we have the object detector. So we are going to see that we are detecting a speed limit, and we'll see what happens after that. I'm going to click play.
current speed is 51 kilometers per hour, but there is a 50 kilometers per hour speed limit in front.
The behavior is as described in the diagram we saw before the video. When the speed limit sign is detected, around here, the last speed that has been stored is 51 kilometers per hour. After that is greater than that, but this is the one that is used to compare with the speed limit sign.